Okay, so we're going to look at how to solve equations involving trig functions. And a lot of this boils down to our algebra skills and our knowledge of the unit circle. And so for each of these problems, we want to find the value of theta that lies between 0 or 2 pi radians. And in fact, we could actually have 0 as an answer. And let's look here, work our way through. So sine of theta equals 1/2. Now this is one of the more simpler ones. I'm thinking, where on my unit circle does sine have a value of 1/2? Sine is the y value. Y values around the unit circle. And the y values are positive 1/2 at pi over 6 and 5 pi over 6. So that one's straight off our unit circle. Okay, and then we slide over to the one next to it. Where does cosine of theta equal the square root of 3? Well, nowhere. There are no solutions here. The square root of 3 is nowhere to be found on the unit circle. And in fact, cosine cannot equal any number larger than 1, because you think about the unit circle. It's a circle centered at the origin, radius 1 unit. So cosine can't, the biggest number it can actually output is 1. Square root of 3 is bigger, so no solution there. Now we work our way down, and the problems start to get more and more complicated as we progress through here. So first thing I normally try to do is with these is I want to isolate the trig function if possible. And these next two examples, it is possible to do that. So I'm looking at the one here on the left, -4 minus 1/3 sine of theta is equal to -4. All right, so I'm going to add the 4 to the other side. That gives me -1/3 sine of theta is equal to 0. Multiply both sides by -3. And I have a problem now that looks like the first two that we did. And we ask ourselves, okay, well, where does sine equal 0 around my unit circle? And sine equals 0 on the unit circle at 0 radians and pi radians. All right, so here's my solution set here. We got two answers. Now on to the one beside it here. So same game here. I want to isolate the trig function so that way I can see exactly what it is supposed to equal and see if I can go hunt it down on my unit circle. Now this kind of problem here, I would not add the 3 to the other side first. In fact, because of the entire right side being divided by 5 and I have that 2/5, I'm going to multiply the whole problem by 5 right out of the gate. So I'm going to times both sides here by 5. And I'm going to rewrite. So that gives me -15 plus 2 cosine of theta is equal to -15 minus the square root of 3. And then we isolate cosine. If I added the 15 to the right-hand side, that cancels out the -15, then divide by 2. And we have cosine of theta equals -square root 3 over 2. And I want to think about, well, where does that happen at? Well, cosine being the x value can only be negative in quadrants 2 and 3. And cosine has square root of 3 over 2 as its value in the pi over 6's. So the pi over 6's in quadrant 2 and 3 are going to be 5 pi over 6 and 7 pi over 6 are my answers. All right, the next few that I have are going to be ones where we're going to have to factor to solve and get an answer. So I'm looking at these next few problems, and I see trig function being squared, a trig function to the 1 power. So I'm going to use my factoring skills to get answers here, which means I need to get everything on the same side and have one side equal to 0. So if I move the 3 tangent squared from the right, and I subtract it to the other side, and then subtract the tangent to the to the left, and I rewrite what I have tangent squared of theta minus tangent of theta is equal to 0. And then we would take out our GCF here, which is tangent. So I have tangent of theta times tangent of theta minus 1 equals 0. And so we have two problems here to solve. Tangent of theta has to equal 0, and tangent of theta needs to equal 1. Well, tangent is the quotient of sine divided by cosine. So tangent is going to equal 0 where sine equals 0, which would be at 0 and pi radians. I'm not including 2 pi because that wasn't in our solution intervals in the instructions. Tangent is going to equal 1 where sine and cosine have the same values. That happens twice. It happens in quadrant 1 and quadrant 3. So tangent equals 1 for the first time at pi over 4, and it equals 1 the second time in quadrant 3, which would be 5 pi over 4. All right, so we have 4 answers here. Now you write them in a solution set from least to greatest. All right, sliding over to the one beside it. All right, this one here. Same approach, all right, I see secant and I see secant squared and I have a constant. So I want to get everything on the same side, put one side equal to 0. So I'm going to move everything to the right-hand side and I'm going to put the squared term first. So 0 equals secant squared theta plus 4 secant of theta plus 4. Now here, this can be factorable. I could just mentally, I could picture the secant function as just being x, and I think of it in my head as x squared plus 4x plus 4 and how that would factor. Well, that's going to factor to secant of theta plus 2 squared. That's a perfect square. So this is the problem that I'm trying to solve. Well, if I square rooted both sides, I'm going to have secant of theta plus 2 equals 0. And which means I just have to solve this one expression. Where does secant equal negative 2? Well, secant is the reciprocal of cosine. So when I'm doing this, I'm asking myself, all right, well, to make negative 2, I had to do the reciprocal of negative 1/2. So where does cosine equal negative 1/2 at? Cosine being the x value, that would be quadrants 2 and 3 on my unit circle, and cosine equals the halves on the pi over 3's. So the pi over 3 in quadrant 2 is going to be 2 pi over 3. And in quadrant 3, the pi over 3 radian measured there is going to be 4 pi over 3. So there's my solutions. All right, next one here. All right, this one looks real ugly, but I have the same approach. So I'll zoom in so I have a little bit more writing room. I need to get everything on the same side here because I see multiple trig functions. So I'm going to move this negative 2 cosine of theta to the other side. And when I do that, I'd have 0 equals the square root of 3 cotangent of theta plus 2 cotangent of theta cosine of theta, and then that's it, because these two would cancel out here. Now, I look at this problem, and I'm going to take out the GCF here, which would be cotangent of theta. Now, cotangent of theta times the square root of 3 plus 2 cosine of theta is my right-hand side. And I solve from here. So I have cotangent of theta equaling 0. And the other side, or the other factor, it's 0, would be when cosine of theta equals the negative square root of 3 over 2. So starting with cotangent of theta equaling 0. Cotangent is the quotient of cosine divided by sine. So cotangent is going to equal 0 everywhere that cosine equals 0 on my unit circle. Well, cosine equals 0 on the pi over 2's. So it'll be pi over 2 and 3 pi over 2. And then cosine of theta equaling negative square root 3 over 2. Well, that's going to be when cosine is applied to a radian value, values of 5 pi over 6 and 7 pi over 6. So 4 solutions to that one as well. All right, next one, more of the same here. All right, I see both sine and tangent in my problem. I need to get everything on the same side. That's my method of attack when this is going on. So I'm going to move everything to, doesn't really matter. I'm going to move it to the right-hand side. When I do that, so I'm still going to have the square root of 3, sine of theta, tangent of theta. I subtracted the 3 sine to the right-hand side. And when I added the 2 tangent theta to the other side, it canceled out. These two canceled out. So I have my new problem here. And just like the one beside it, we're going to take out the greatest common factor, which would be the sine function. So it'd be sine of theta times the square root of 3 times tangent of theta minus 3. So our solutions here is going to be when sine of theta equals 0 and where tangent of theta would equal 3 over the square root of 3, which I could rewrite that if I multiplied both sides by the square root of 3 over 3, or both the top and the bottom to rationalize. Here we would have 3 roots of 3 over 3, and the 3's would cancel, and I'd have the square root of 3. So where tangent of theta equals the square root of 3 is going to be one of mine, and where sine of theta equals 0. Well, I'm going to start with the sine one. Sine being the y value on the unit circle. Sine is going to equal 0 at 0 and pi radians. All right, tangent equaling the square root of 3. Well, remember that tangent is the quotient of sine divided by cosine, and to make the square root of 3, I would have to be dividing the square root of 3 over 2. That would have to be divided by 1/2. So sine, which is y, divided by cosine, which is x. So the first place that would happen would be pi over 3. The second place where I could have tangent equaling the square root of 3 would be if both the square root of 3 over 2 and the 1/2 were negative, which would be in quadrant 3. And that would be 4 pi over 3 radians. All right, next one here. All right, and this is the first one that we've seen here in this video where we've had a function inside of the trig function. Now, that doesn't affect the way we start, but it does affect the way we're going to finish. And so I want to begin the problem. I will need to isolate the tangent function so that way I can figure out what tangent has to be applied to. So if I multiplied, my first move would be to multiply by 4 on both sides. So I'd have 8 minus 3 tangent of negative 4 theta plus pi over 3 is equal to 8 plus the square root of 3. And I got rid of the denominators of 4. And then I would subtract 8 from both sides and divide by the negative 3, multiplying the tangent. And I have this. Tangent of negative 4 theta plus pi over 3 is equal to the negative square root of 3 over 3. And so at this stage, what you're going to do is I'm going to think of this problem a little bit differently. I'm going to just say, all right, let's pretend like the negative 4 theta plus pi over 3 is really just an x. So where on the unit circle does tangent equal the negative square root of 3 over 3? That's what you're asking yourself. Well, tangent equals the negative square root of 3 over 3 when I have opposite signs for x and y. So this would be quadrants 2 and 4. And that's going to be at 5 pi over 6 and 11 pi over 6. Now, I'm not done. Those are just the values that tangent has to be applied to. Now, these problems take up some room when I'm working my way through solving. And so I'm going to scroll down here some. And I need to I'm going to start with 5 pi over 6. And I need to solve for theta. That will make me put a number in for theta and equal 5 pi over 6 so tangent can be applied to it. So 5 pi over 6 equals negative 4 theta plus pi over 3. And then I would solve. And so I work my way, I solve for that. You have to get common denominator, so I subtract the pi over 3 to the left and then divide by negative 4. And we'd get theta to be negative pi over 8. Now remember, our solutions for theta have to be from 0 to 2 pi. And so this is not a solution that I would use in my solution set. Now, at the same time, let me change colors here. We had another possibility that tangent could be applied to, and that was 11 pi over 6. So right up here, up under it, I'm going to say, all right, well, let's try 11 pi over 6. Set that equal to negative 4 theta. And then I'm going to resolve. So I'd subtract the pi over 3 to the left, and then divide by negative 4, and we get theta to equal negative 3 pi over 8. All right, so I actually went the wrong direction. By increasing the values from my unit circle, I ended up getting theta values farther away from acceptable solutions. So this ties in to coterminal angles. Remember that I can get the same values for my trig functions by using or increasing the number of revolutions around the unit circle. So, like for instance, tangent of 11 pi over 6 is going to produce the same value. So I'm going to actually reduce my radian value, so that way I'd be heading in the other direction. I'm going to subtract the revolutions. I'm going to subtract 2 pi radians. 11 pi over 6 and negative pi over 6 land on the same spot on the unit circle, which means that tangent's going to have the same value. So I get this new radian measure from my coterminal angles, and I'm going to set it back equal to what's on the inside. So that way I can get a value for theta and see if it works. So from here, right, same game, subtract the pi over 3, I divide by negative 4, and we get positive pi over 8. Hey, there's a number for theta, or a value for theta that would work. Now, I don't stop just because I got one. I want to keep going, and because there could be more values of theta. So I'm going to take my 5 pi over 6, and I'm going to get a coterminal angle for it as well. So I'm going to subtract 2 pi radians from it. So 5 pi over 6 minus 2 pi, that's going to land me at negative 7 pi over 6. Set that equal to the inner function of tangent here. And then I'm going to resolve. So negative 7 pi over 6 minus pi over 3 divided by negative 4, 3 pi over 8. Hey, I got another solution that works there. Now, I could continue this process on of getting coterminal angles for all of the values that lie on my unit circle. I could keep getting those coterminal angles and resolving. And eventually, I would get to a point where I've gotten all the values on of theta that would work. However, there is also a pattern that will exist in your answer solutions. Now, they will either be equally spaced or they will alternate in their spaces in between them. And I'll show you what I'm talking about. I'll start with the one on the very bottom. To go from negative 3 pi over 8 to positive pi over 8, I add 2 pi over 8. To go from negative pi over 8 to positive pi over 8, I add 2 pi over 8. To go from positive pi over 8 to 3 pi over 8, I add 2 pi over 8. So the pattern that lies here is between your answers, possible answers for theta, you keep adding pi over 4 or 2 pi over 8 to the previous one. And so instead of me resolving, I'm just going to copy that pattern. So I have the first answer we have for this solution set was pi over 8. And then the next one we got was 3 pi over 8. Now from here, I'm going to add 2 pi over 8 to my answers each time until eventually I get a number that is too large to fit within the possible intervals for theta. So I add 2 pi over 8 to 3 pi over 8. I get 5 pi over 8. Then do it again. 7 pi over 8. 9 pi over 8. 11 pi over 8. 13 pi over 8. 15 pi over 8. And if I go one step farther, they give me 17 pi over 8, which is bigger than 2 pi, so I stop. Here are my solutions. All right, and one more example. All right, so this one is similar, but instead of having a positive angle in front, or on the inside, a negative theta, excuse me, I have a positive theta. Let's see how this one will play out. Now, I take the same approach we've done with all the other ones. Isolate the trig function. So I want to subtract the 4, divide by negative 3. So I do that. That's going to give me negative 6 divided by, I get 2 equals cosecant of theta divided by 4 plus 3 pi over 4. And we'll do the same approach. Just say, all right, we'll temporarily let the inner function be x. And so I'll go to my unit circle and say cosecant of what numbers makes 2 on the unit circle? Well, cosecant's the reciprocal of sine. So cosecant will equal 2, where sine equals 1/2. Sine equals 1/2 at pi over 6 and 5 pi over 6. So now we're going to start. I need to figure out what values of theta can be applied to those, to create those x numbers that we have from our unit circle. So I'll start with pi over 6. So I'll say pi over 6 equals theta over 4 plus 3 pi over 4. And solve for theta. I do that, subtract the 3 pi over 4, then times by 4. We get negative 7 pi over 3. Now, that's a value for theta I could put in and make this a true equation, true statement. However, it lies outside of the interval, so it's not going in my solution set. Now, we'll do the same thing with 5 pi over 6. And say, all right, well, 5 pi over 6, I set that equal to what's on the inside. Solve for theta. So subtract the 3 pi over 4 to the left. You have to get common denominators, multiply by 4 after that, and we get theta to equal pi over 3. I have a possible answer here, or I have an answer here. Now, I don't stop because I have one. I want to continue the process like the previous example to see if there is more than one solution. So I'm going to take the pi over 6, which was my first solution. I don't want to be subtracting revolutions here because this one's already negative. So I want to continue to go where my unit circle numbers are getting larger. So I'm going to add a revolution. So if I continue to rotate around, the first one of these radian values that I have listed for x that I'd get back to would be pi over 6. Pi over 6 plus 2 pi is 13 pi over 6. So I have a new radian value if I were to keep rotating around the circle, and I'm going to set that equal to what's on the inside of the trig function. So theta over 4 plus 3 pi over 4. And then I'm going to resolve. So subtract the 3 pi over 4 to the left-hand side, then multiply by 4, and we get theta to be 17 pi over 3. That is a lot bigger than 2. So our answer here, our only answer,